says shamelessly plug our Meetup group, Bots and Brains. And if you're interested in sort of this cross between neuroscience and AI, highly recommend you check it out. So I've been interested in AI for a while, and I've been teaching myself a lot of the deep learning stuff. And so I was curious how I could sort of bastardize both of these algorithms and sort of glue them together. And sort of a contrived example that I came up with was a Duck, Duck, Goose game. Everyone remembers Duck, Duck, Goose as a kid, right? You walk around the circle, you're patting people on the head, duck, 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 and eventually you hit to goose, and it's an anomaly, right? So what I wanted to do was, NuPIC cannot, as far as I know, really handle image data. It's just much too large, and there's not a hierarchical representation. But deep learning actually is really great at getting the underlying features and the underlying hierarchy of the image itself. And so what I decided to do was try to see if I could use I hear it coming. See if I could use the deep learning network as a feature detector that I could use to actually generate the SDR automatically for the images. So I used a set of images from ImageNet. And if you haven't heard about ImageNet, this is what everybody's crushing right now with some of the algorithms lately. And what they do is they basically have labeled data. They have a picture of a duck in this case, and then they have someone's labeled it with duck. But in this data set, there's only 1,000 categories, so they had to be selective. And interestingly enough, duck is not one of the categories in this data set. They've got all kinds of weird, other strange, exotic birds, but they don't have duck. They have goose, but they don't have a duck. So I thought a lot of when you get these results back, and I wanted to show you that real quick. When you get the results back, they're effectively probabilities. So even though it's not a duck, they don't have duck, it gives suggestions that are similar to duck, right? It gives a lot of the other birds. It's going to take me a minute to scroll up here. And so you can see, it's really dark. 1 second. So these are some of the categories that come back, right? So for this one, its first guess was, let me see here. For this one, its first guess was that 73% chance that was a goose, whatever that was, right? Then its second best guess was 21%, it was an albatross. Oh man. We're in trouble. Okay. And then at only a 2% chance it's a pelican. So what I thought was I could take the top 10 results, even if they're kind of crappy, like American egret, whatever I assume it's a bird. A heron? Yeah, that's some sort of bird. So it's only there as 1%, but it still informs this general idea that these things are birds, right? And so even though there's not a duck representation, there's at least a bird representation just by kind of subsampling here. I wanted to go further than this and actually remove the classifier and actually get at some of those underlying features, but just kind of ran out of time. And so the sort of dumb idea of the game is that you're playing Duck, Duck, Goose, and as you click this, you can see these the top 10, or some of them like goose were actually so popular. So there's the SDR, right? I tried to format it like something like you guys recognize. So in this case, it was, here's 3 categories for this image, right? That it said, these were the top 3 guesses for that image, right? And only of the 1,000, in the data set categories. And so some of these have 10, some of these have 1, but most of them have something. And so I'm very ready to move forward with it, but I want to dig into those underlying features and actually get this much more less sparse, I guess you'd say. So that was my project, and it's up on GitHub. So check it out.
So Frank, what was what you said you want to take it forward, aside from getting less sparse representations, what do you think would be an application for this to pass these into HTM?
Well, they seem like neural networks or deep learning networks are not really great. They have some temporal components that they're adding now with recurrent nets, but the sort of long-term, and they're very, compute heavy. And so I'm thinking that we could sort of get the best of both worlds. What deep learning nets are really great at is that sort of encoding. So we've all been doing the who's like trying to figure out how do I encode my data today, right? We were all doing that. Well, the deep learning stuff is really good at least with certain types of data, like images, of actually generating that sparse representation for us. So my interest is like how I can actually take that data and then kind of glue these two algorithms together. So we started that process, but we're a little more to go.
Questions?
Umbrellas.
Are you using a particular deep learning library?
Yeah, I'm using Torch, and just happened because I'm taking Jan LeCun's giving a course at NYU, and he's putting all the videos up online. So if you're interested in that.
Yep.
Thank you, Frank. That's very cool.
Yep.
Okay.
One more shout out about bots and brains. Check it out.
Bots and Brains Meetup, New York City.